Alrighty, looks like a medium today. Maybe it won't be as difficult. Maybe it'll be solvable. You're given an m by m integer matrix grid. M is the rows, I guess. A rhombus sum is the sum of the elements that form the border of a regular rhombus shape. In grid, the rhombus must have the shape of a square rotated 45 degrees with each of the corners centered in a grid cell. Okay. Below is the image of 4 rhombus shapes with corresponding colored cells that should be included in each shape. Sure. Note that rhombus can have an area of 0, which is depicted with purple rhombus in the bottom right corner. Return the biggest 3 rhombus sums in the grid in descending order. If there are less than 3 distinct values, return all of them. Okay. Return the biggest 3 distinct rhombus sums. If there are less than 3 distinct values, so if there's like 2, 1, 1, then just return. Okay, so if there's duplication in the top 3, then just return duplication. But if there's not, no. If there's less than 3 distinct ones, then just return those 2 or 1 distinct ones. I see. Is there an example of that one? 777, yeah, it returns just 7. Okay. How does this work? 777. Okay, because it's just like centered on the 7. It's like 0-dimensional or like a dot. Okay, so these interesting. Kind of trippy, huh? Kind of trippy. Wonder if I can rotate this to make it easier on my brain. Rotate it into a diamond shape and then try to do like this is the top of the diamond, row 1, row 2, row 3, and row 4 of the diamond, like diagonals. And then you're gonna match things in the same column. Yeah. Maybe that's not, well, is it? If I rotate it, then I'm dealing with every other row. So index 0 of row 1 and index 0 of row 3. Assuming I rotate it like counterclockwise 45 degrees. So like it'll be 3, 2, 6. And I guess the 3 is actually on top of the 159. So it's like 159. And then the 2, 6 is on top of the 4, 8. Okay. So the 3, 1, 5, 9, 7, they can't really form a rhombus at all. So the first one is something like let's see, 3. So let's say the first one is 3, and then the next, and then 2 rows after that it's going to be 5, 2, 10, and then 2 rows after that it's going to be 3, 3, 200, 4, 5, and then 25, 2, 4. Spacing's a little awkward, but kind of get the gist of it. So within this, select 5, 2, 3, 200 is 1. Yeah, maybe this is just easier to work with, so kind of separating out into 2 versions. One is the kind of odd row, and one is the even rows. Odd diagonals and even diagonals. And then I can more easily come up with the rhombus shapes within those. So 1, 5, 2, 10, 3, 25, 2, 4, 5, 2, 10, 3, 5, 2, 10, 4, 2, 5, 23. Lots of layers in this one. How would I, given a shape like this, how would I determine the largest rectangle at that point? The largest, no, it has to be a square, right? It has to be a square, it can't be just a rectangle. Yeah, rhombus, the rhombus must have the shape of a square. So 5, 2, 3, 200, 2, 10, 204. So how would I get that? How would I get those sums quickly? So if I have a particular position, this cannot possibly be that efficient, right? It's not linear. Oh shucks. That is a pretty... Okay, the values are between 1 and 100,000, but yeah, the size is actually pretty small. 50 by 50, because I don't think this... I mean, I feel like you probably need to go n squared here. Probably need to iterate over like every combination of starting point and ending point. Is there a faster way of doing that? Every kind of possible starting left corner and bottom right corner. Feels like that would be n squared. This would probably be bigger if it was possibly done in linear time. I can't imagine being done in n log n, because why would you ever sort this? I mean, maybe if you had a heap somehow. 5. So you'd... 5, 2. Actually, I mean, can I even do it n squared? Do I have to do n to the 4th? 5, 2, 3, 200, 5, 2, 10, and then that would need to match with 25, 2. Is the dimension of the original thing a square? No, it's an n by n, so it's a rectangle grid. just these examples are squares. Okay. I mean, I guess I could probably do a prefix sum thing here to quickly calculate the summation of things. Prefix sum to summation various parts of it. Ooh. For every possible upper left corner and then every possible size from that position. Okay, guess I just need to start coding. Do I want to use this? Maybe I should position this point as my top rather than this point. So I'm going to rotate it clockwise 45 degrees. So let's say, so let's do a simple example. Let's say it's 1, 2, 3, 4, 5, 6. So if I rotate it 45 degrees clockwise, the 1 should be on top of the 5, so something like 1, 5, 3, and then the 2 is on top of the 6, up to the 4. And then be 4, 2, and then 6. Alright, kind of weird. Alright, maybe I should do it bigger. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to make something that's not square to make it harder. So if I rotate that one 45 degrees, it would be uh, 1963 and then 11 there, and then 5, 2, 10, 8, 5, 2, no, it's 10, 7, 10, 7, 4. And 12 underneath that. Seems wrong somehow. I guess that's fine. This is 5 numbers, and that's 7. No, that's 6. I'm missing one. 1, 9, 6, 3, 11, 8. Whoops. Okay. So that is rotated. 1, 9, 6, 3, 11, 8. So how do I get this correct spacing for it? So 1 lines up in front of this 6. 9 is gonna line up. Oh boy, oh boy. I guess maybe I can make it, I can generate a square version of the m by n grid. Fill it out with zeros, maybe. Fill it out with zeros. How would that work? So then then I know this corner is going to be one of the corners. So like if I start with that corner, say 0, 10, 7, 4, and then build from there. So then the 5 would be on top of the 10, 5, 2, and then that's it. And then the next one would be 0, 12. Is that roughly right? Yeah, 5, 7, 5, or the numbers in this thing. Okay, the numbers in the grid are non-zero, they're positive. So if I see a 0, that means it's actually a blank. I can treat it as a blank. So 5, 2, 10. So I pad the grid with zeros. And maybe that'll make it a lot easier. It'll standardize what it looks like to get the diagonals. So 9, 6, 3, 1, 0, 11, 8, and 0. One, 9, 6, 3. Okay. Standardize grid, rectangular grid to be square. So say rows and columns equals the length of the grid and the length of the first row in the grid. Same thing as M and N, just I prefer calling it rows and columns. And then, so I need to pad it up. So how would I do the padding here? So I think if A is less than the number of, no, if the rows is less than the number of columns, okay, let's go ahead and say size equals it's fine. Rows is smaller than the number of columns. Then I need to add more rows, right? So if there's like 4 rows, 5 columns, I need to add another row. So grid.append. So for every thing in range of the difference, grid appends the number zeros times the number of columns, right? And I'll say the size is now based on the number of columns, or the size of one side, the size of one side of the square. Else for every row in the grid, need to extend the row by the difference. So row.extend 0 times cols minus rows, and then size is number of rows. Okay, so let me do a test case here. Do I guess that's fine. This should make it into a 3x3. Yeah, it made it to a 3x3. Just need to check the other way. So if this thing was a 1x3 or 3x1 originally, so if it's like 7, 7, 7, just need to check this makes it into 700, 700, 700. That did not work out, huh? Well, whoops, this should be calls minus rows. Or rows minus calls, since that's the bigger number. Okay, so I made it into a 3x3, sure. Okay, so from there, I'm going to go ahead and try to do the rotation or get the column. So if it was something like 700, 700, 700. Actually, maybe make this 1, 2, 3. So 1, 3, 0, 0, 0. Can I mathematically determine where 1 starts at? So if it's an odd number, if the size is an odd number, then the first element should be the middle of the diagonal length, then the main diagonal length is going to be the size. If this was a 4, or if this was an even number, then the starting point is 1. So the main diagonal is going to be on the odd, if the size is odd. Or the longest diagonal is going to be odd. Okay, so let's go ahead and base it on the odd version to be fair. If size is odd, then how many rows will there be? I think there should be the same number of odd rows starting with the initial value. So let's say I'll call these the odd diagonals. Odd dag. Odd diagonal. I mean, I could make it into a 3x3 as well, right? I know that it's going to be, yeah, I know it's going to be 3x3, huh? 3 diagonals, 1, 3, 0, 0, 0. Yeah, so maybe I can say odd diagonals should be equal to 0 times size for every thing in range of size. Or this using list comprehension maybe. rather than using for loops here. I almost certainly can do this with using list comprehension rather than manually iterating over all the elements. So it'd be 0. My brain. So if I just iterate for every R in range row, so the element 1 goes into the first row, middle index. So for every R in range rows, no, in range size, iterating by 2, no, iterating by 1. So 1 needs to go into the first row on diagonal middle column. So it should be something like odd diagonal at R for the index of the row that's going to be n. And then the column index should be the middle column index. The middle column index minus the row index divided by 2. So it should start with the middle index. The 0, 0 gets translated into 0, 1, and then for R in range size, for every row in range size, so row R should be thought of as the diagonal I'm dealing with. So, whoops, what am I doing here? This is R. So R, yeah, whoops, what am I doing? And then this should be for every column in range size as well. And then this should be something like, if it's out of bounds, then skip it. Just keep it as 0. So if what I'm dealing with, if I'm dealing with odd diagonal of 0, 0, this should be out of bounds, and then 0, 1 should be equal to 1. And then 0, 2 should be out of bounds. So 0, 1 is out of bounds, or 0, 0 is out of bounds, 0, 2 is out of bounds. 0 is out of bounds, 2 is out of bounds. So let's see. Out of bounds is 0, 0, 2, 0, or 0, 2, 2, 0, and 2, 2. And inbounds is 0, 1, 1, 0, 1, 1, 1, 2, and 2, 1. So what's the pattern here? Center is 1, 1. So everything that is within 1 difference from 1, 1. So 1 difference from 1, 1. So the difference between the column values is greater than the difference between the column values, the difference between the row and column indices is greater than a certain value. Okay. So if the absolute value of the row and the difference between the row and column indices is greater than, so if this is a 5 by 5, then I want to say this is a 5 by 5, then we're dealing with 0, 3, no, 0, 2, 0, 2 is the center, 0, 0, no, wait, what's going on here? 0, 0 is, 0, 0 is out of bounds. That's not really the difference between them. 1, 1. It's the difference between the center value and the row index and the center value and the column index. So maybe I can define the center as equal to the size divided by 2. So here the center is at 1, 1. If this is a 5 by 5, the center is at 2, 2. So if the sum of the difference between the positions by 2, okay. So I think it's something like absolute value of R minus center plus absolute value of C minus center. If the sum of that is less than or equal to the value of the center, then this is fine. Or I guess if it's greater than the center, then this is gonna skip. Okay. And then otherwise odd diagonal of RC should be so 0, 1. 0, 1 should pull from 0, 0. 0, 1 should pull from 0, 0. So what's the translation there? Or transformation there? 0, 1. Zero, 0 gets translated to 0, 1. Row 0. 0, 0. 0, 0 gets translated 0, 1. If this is 5 by 5, 0, 0 gets translated to 0, 2. This is 5 by 5. The only thing in the first row okay. Gotta remember how I work with diagonals and indices. I think it's something like one of the diagonals, the sum of the values is the same, and the other diagonals, the difference is the same. Like in the diagonal that goes from bottom left to top right is 1, 0, 0, 1. 2, 0, 1, 1, 0, 2. So the sum of the values of the row plus column index is the same if you're dealing with the diagonal kind of to the northeast to the top right. So this first one adds to the first diagonal, which is at 0. This next one adds to the 2, and this one adds to 4. The sum of the values adds to unfortunately that's backwards. Because I'm iterating over the position of where it ends up rather than the position of where it starts from. RC. Odd diagonal, 0, 0 is out, 0, 1 is there. So 0, 1. Actually, maybe I should do the second column. So, or second row. So the row with 3, 0, 0. So row 2 comes from the things that add up to 2. The things that add up to 2. First row comes from the things that add up to 0 to the row. So the indices needs to add up to the row. No, if row 1 is going to add up to 2. Row 0 adds up to 0. Row 2 adds up to things. Things that add to 4. Row 2, column 2. So I want to say it's something like from the grid so R for every column, row, column, everything in this column. Everything in this column. So 1 total is equal to row times 2 plus row times 2. Yeah, okay. And I think this should be something like total grid at which row and column. So 0, so the total is going to be 0. Total is going to be 0. Row 0, column 1. Row 2, column 1. Row 0, column 1, row 2, column 1. Total grid at total minus row. So if row is 1, then I'm pulling from 3, 0, 0. 3, 0, 0. Sum of the row and column indices is 2. Row 0, row 0, column 0, 1, 2. Row 1, column 0, 1, 2. Alright, come on. Just not my day. Alright, it's time for bed. I don't feel great about this. Definitely not. Man, 60% got it. I'm just complicating this too much. Alright, time to go.